Hello.
Hey.
Back.
Yeah. Okay. I'm having some kind of issue with my headphones. Why don't we wait a moment and see how many other folks we get? And we'll continue trying to get my headset to work.
All right.
Can you all hear me?
Loud and clear.
All right, great. Fantastic.
Get your headphones sorted.
So sorted.
Awesome. All right, we're
all right.
after.
Yeah, let's do it.
All right, so this is the SIG Multicluster meeting for Tuesday, July 27th, 2021. And John, it looks like you have the floor today.
Cool. Hey, everyone. I am John. I work on Istio mostly. So we have been looking into MCS quite a bit. I actually personally haven't been super involved with it, but the person who is, I think, is unavailable today. So I am here in their place. So I may not be an expert on everything. But one thing we wanted to discuss was around leader election. So one thing we've noticed is, we're using a standard client Go leader election package right now, and we're kind of hitting the limits of it, especially once we go into kind of having these globally replicated controllers that are, syncing these service exports and service imports, across different regions. So for example, like one concern we have is that, say we have, some clusters running in Asia and in America. If the one in America gets a leader election lock, then now it's like in charge of Asia, and we have all these egress costs and latency, et cetera, for this cross-globe replication. When there's perfectly fine controllers that are running in Asia at the same time that could easily just be the leader for their own clusters, and reduce latency costs, et cetera. But the problem is we don't want to just restrict it only to that, because in case the ones in Asia go down, we of course want to fail over to the ones in America. So just general problems like that. There's also other use cases for, kind of improvements to the leader election, such as one thing we have is we'll run multiple versions of Istio in the same cluster. And this is just a kind of a general problem, not even multi-cluster service discovery specific. And we want a specific version, which is dubbed the default one, which is generally the latest one that's not just a canary, to be a higher priority to become the leader, because it's hopefully better than the other ones and can act in better ways. Today, it's just kind of first one wins. So you may end up with some super old version becoming the leader and kind of behaving less optimally. So I kind of put together this KEP that's in the meeting notes for adding this concept of kind of prioritized leader election. And the idea is actually pretty simple. I was surprised how easy it was to implement. Basically, each participant in the election would just be able to assign themselves an arbitrary key. So this could be anything. If you were doing something with versions, for example, you could say, you could put your version in the key. If this was about like the region, you could put what region you're in, or obviously you could put a JSON blob if you're doing something, complex. And then each participant also has some sort of function to determine how their key compares to the existing leader. And so if they decide that they have a higher priority, then they'll just take the lock even if it's held. So that way, if I say, hey, I'm a newer version than the current one, I just take the lock, I start doing my leader election activities. The old version realizes someone's taken the lock and they stop leading and everything should work smoothly. Yeah, that's pretty much it. I feel like I've been talking for a while, so I will open to comments or questions.
I mean, I think all those use cases definitely sound reasonable. I think, here in this SIG, obviously we're most concerned with that multi-cluster case. And so I'm curious, because when I was reading through it, there's a few questions that kind of popped out. Like, is the assumption that there's like one controller instance in Asia responsible for all of your clusters in Asia, or is it more like a cluster or a controller per cluster, and you just kind of want to prefer local?
That's a good question. I think you'd probably, in the simplest case, you'd have many clusters, which could be in many different regions, and you could have multiple clusters in the same region. They probably all have a controller, perhaps, or maybe some would and some wouldn't. But we also pretty regularly support multiple versions as well. So you may need to kind of do both, like not just like by version and by region, if that makes sense, which that may get kind of complicated. Like you need to be, I don't know, like all the controllers obviously need to have a similar logic for taking ownership. Otherwise, they'll just steal ownership from each other, which is problematic. So I'm not sure exactly what happened there. But for us, we do support multiple versions at once. So, and obviously multiple clusters and multiple regions. So there's kind of any topology is possible.
Okay. Yeah, kind of what I'm getting at there is so like this is in this vein that has kind of come up recently of like now that we've really started to figure out how to deploy things across clusters, connect things across clusters, coordinating things across clusters is kind of a natural next step for sure.
Yeah.
But in this case, like I'm trying to understand. So if you have a replica in each cluster, and that would be the preferred controller for that cluster, like what scenarios might that controller not function, but the cluster API is still up, for example?
Yeah, so I mean, downtime is something that's always possible. It could also be that they choose to not deploy a controller in that cluster, at which point that is something that could be solved by like coordination between all the clusters and say like, hey, all of these other clusters, like this one doesn't have a controller, so you actually are responsible for that one. But then any new clusters you add, you need to have like this cross-cluster coordination and tell them, figure out who's responsible for which cluster, which can get complicated. Whereas with this prioritized, it could be all sort of dynamic. But also, yeah, just like reliability, the controller could, in theory, go down at any point. So it would kind of suck if your controller goes down in one cluster and you have 10 other clusters that could easily do the same job, but they're just not looking at to take the leader election lock.
Yeah, that's that to me sounds pretty reasonable. I'm also curious about a different use case so I think this makes a lot of sense for when you're trying to control things like in clusters in a region, but everything is generally homed within a cluster, which sounds like the core case. Another case that's come up is when you have controllers spread across clusters responsible for global state. So there's no like natural place for leader election to live. Like obviously, if the resources you care about are in a cluster, having leader election live in that cluster makes sense. If your resources are global, then it's less clear. I'm curious if Istio has those kind of use cases as well.
Yeah, that's a good question. So generally, like we have kind of two concepts typically, and we support like all these different crazy topologies. But the most common one is we'll have like a single config cluster, which stores like the Istio configuration. So it's like routing rules and TLS policies and whatnot. And then we'll read from a bunch of clusters for like endpoints and services. So kind of the service discovery aspect. And so there is kind of this centralized location, like we call it a config cluster. It's kind of like the core cluster. I'm not super familiar with it, but I think multi-cluster ingress on the GKE side does a similar thing. So it seems like there's some prior art there. So I don't know. There's other multi-cluster things as well, like Cilium. I don't know if they have a similar concept, but it seems like it is definitely something that needs to be solved by almost all things doing multi-cluster. But it gets a bit more confusing in our case because we have, like, you can have multiple primary ones, and then the user keeps them in sync, which is both good if you like to slowly roll things out and you have a great CI pipeline, or bad if you don't, and now you have to keep things in sync, and that doesn't work well. So right. There's kind of pros and cons.
Right. Okay, cool. Yeah, I mean, for that first problem, from my reading of this KEP, I think I need to go through it, but it seems pretty reasonable to me. I think that second problem, it would probably be good to have like some Istio folks come weigh in. I think we've just started kind of exploring some ideas around that in the last couple weeks. So maybe that would be a good ongoing topic. Yeah,
I think that would be good.
Awesome. Does anyone else here have anything else to add? Thoughts?
Unfortunately, I've had a very inconvenient series of distractions while we've been having this meeting, but I do wonder if like the challenges that John described like are ones that other folks on the call have faced in similar domains.
Sorry, I was talking on mute. So in one of the solution, not really, it was kind of a federation overall, not really in the context of Kubernetes multicluster, where we kind of wanted to enforce who is going to be master, but we kind of took a route to kind of, explicitly, kind of influence the election mechanisms to kind of choose the master. Rather than they kind of choosing it automatically based on attributes like priorities or what type of cluster they're handling and all those kind of a thing. So yeah, it was not automatic, but kind of user force. But the frequency for that operation was need based. So it was not very frequent. So that way we were kind of, we were able to do that with kind of, from a user's point of view, that if you user want to make any specific controller a master, it can go and choose the master. So at that moment, it actually gives the locks to it and it becomes master. But obviously, it work and scale better if the frequency of that choosing master is going to be less. Otherwise, you need to kind of rely on attributes and using those attributes to kind of influence the election mechanism.
So I did have a question, like from a use case that I kind of half heard, like when you said that in the use case where you have multiple versions, and you want to choose generally the latest version that isn't a canary. Is that part of like a deployment flow where like you maybe have versions A, B, C present in a cluster where like C is the newest and you maybe want to roll out D and like evaluate things scoped to D in some kind of like health check or EDE before you make D the one that should be the leader? Is that sort of like what the encompassing flow is like?
Yeah, I think if you just think of the general case, like it would be perfectly reasonable to just say just newest version. And if you didn't do canaries, then that's fine. Like you would just make your comparison function. Like if my version's newer, then you're good to go. And that would work for a lot of users. For us in particular, we do have that sort of canary. Like we allow people to roll out a new version, do some tests. Like Istio is kind of like the control plane for pods, right? So basically what users would typically do is they deploy the new version, roll over a few kind of test workloads, make sure things are working, and then move everything over and kind of market the default. And so we would want that default one to be kind of the leader. But I think, I mean, I could certainly see in a different scenario where they don't have kind of this default or canary concept and it's just latest version wins.
Okay. Yeah, I think so. I was like chatting a little with Jeremy on the side. I think a picture would probably help me understand the topology in the multi-cluster case. Like and I don't mean that to be any like value judgment on like what you propose. It sounds like a very valid real use case for me. I just like every time it happens that we've talked about this, I've been terminally distracted. So I think perhaps Jeremy and I will try to draw something up offline and we can make sure that we're thinking about the same thing. Sounds like a very interesting use case to me though.
Yeah, I'll take a pass at that diagram and share it around. And then maybe include in the cap as well, if in fact it is the correct diagram. I think, yeah, it would help kind of just like show which topology scenarios, like which multi-cluster scenarios this actually addresses and what the failure modes are.
All right, well, thanks for coming and chatting with us. Do we have anything else on the agenda today? I'm sorry, but I haven't had a chance to look yet. It's been a day over here.
No, I think that this is our agenda for today. Yeah, I don't see anything else this week.
All right, well, sounds like we can get our time back. Thanks everybody for joining. We'll see you in 2 weeks since we're doing bi-weekly meetings now. And everybody have a great day.
Awesome. Thank you. Thanks, John.
Thank you, John. See you, everyone.